you are dealing with naive Bayes. It's naive because it's assuming that all the independent variables are completely independent, which is generally not the case, but it's what makes this naive. Of course, Bayes is referring to probability, and so what we are going to be doing a very simple example, not really a complicated one. So actually I forgot to mention that naive can also be used when you have multiple levels or multiple factors. If you know your dependent variable goes beyond the 2, and you're going to use to try to predict insurance or based on a doctorized data set that's available in website. So here you can see this for multiple levels we are only going to do a basic two-step classification. In other words, we are going to have two classes. We are going to discriminate our dependent values. If you will see that here our modules that we are going to use. So in line 1 we got pi data. So when it is a dummy data from, if you choose pandas, here Scikit-Learn model. So in the next line we are having a selection training test splitting, and we are going to create our training data set. Then we are going to use our closed classification report. So for the classification, here we are going to create a data set from the available data. So here we are having our actual data set, the Dr. AS. So sharing in medical information for people and what kind of insurance they have for our dependent variables. That's a lot of them. Here you can see. So using the data function, so if you will use the argument show docs equals true. So these are our different independent variables, and of course y is going our dependent variable. So run this. This is the output for the actual data frame. So before we separated the things, so start here is the insurance thing. So notice how is the text. So normally Python has a really hard time with the text for prediction, but naivebayes is able to do that. And of course naivebayes is often used for text classification in situation like this. So you can see we have a lot of our variables. So here of the side again you can look up the details on your own time about the characteristics of each of this data. So these variables that we are going to move on here and go down here. So again we are going to set up our train set values. So x training, x text train, y text. So alright, success. So is separating our independent variable into two objects, y train set and y test. It's also separating two different objects, and then the function we are using is the train test split. So we are taking this stuff from the x and y object that I created before. So I think you remember the text size equals 0.3. That means 30 of the data is going to be set aside for the testing, and the random state is like the seed number. It's set to 0. So next we are going to get and set up our model here and train that. So we make an instant of it, then we train it. So the output is not that existing. So we first we call that function as a Gaussian naive Bayes. So here can have a dot function. So the model has to fit. So we didn't really set any hyperparameters. If there is any, we are just showing you the basis of how to do this in Python. And the last thing we are going to do is we have to evaluate our data and the model that we are going to set up and share with you the outputs here. So in the next line we set up object. So we are predicting this with the help of y underscore prediction PRED that came up from using the dot predict function. We are using with the x text and text data. So it will show us the different metrics for classification. So based on your y underscore test and y underscore prediction, so that the test and predicted data. So this is a predicted result. So here you can see that the numbers actually there are 4 different classification. So precision recall F1 score support values that we predicted. So this value that recall, it's somewhat 0.81, and the rest of its the overall accuracy you can see somewhat around so 0.51, 0.51, 0.48. So here make sure we didn't have two classes, we actually have four earlier. So four different classification. So we have predicted those functions. So we look at collecting more data, adding more variables, doing something to try to strengthen our model. Here is the base model. So let's go back and see what we did, and we can conclude this. So we are exposed to naivebayes, another useful tool for making predictions in Python. And so what we did here was we looked up the setting up our data set right here by separating the dependent and independent variables, and then from here we displayed it from just you can see there are four different levels. So among the four different levels we have to discriminate the right here in this particular cell. So you now separated our training and test data set, then our model, and then did our evaluation right. So here are results that we obtained. So we can try with some more examples also. We can predict the values better way. So thank you for watching the video. Meet you in the next